To a video on linear functions. In this video, we're going to be reviewing some key concepts in linear functions. It'll probably be cut up across a few videos just so they're not super long. And where you can find this is the sheet I handed out a while ago. It's on test 2 and then linear functions. If you want to go there, just to have a look at it. And up will appear the answers too. Okay, so let's just going to go down these columns as we go along. The first thing we're looking at is something called coordinates. So when we think of the word coordinates, we're thinking an x and a y. And it all comes from something called the Cartesian plane, where you can plot a coordinate. It's a location that you can just pinpoint a location by giving it an x value and a y value. And with that, you can go anywhere over an area, which is pretty great. So consider the Cartesian plane below. Find the coordinates of the following. So we're just going to go through here. X is 1, so this is a positive 1 this way, and then it's going up 2. So this is our x, this is our y. The answer is 1, 2 there. Okay. B, this one is going across 3, so x is 3, and y is going down 2. And just a reminder, this is the x-axis here, and this is the y-axis. Okay, so B's 3, negative 2. C, it's going negative 2 for the x and then positive 3 for the y. D, it's going negative 2, negative 1. So E, it's 0 for the x, so it's not going across at all, it just stays there. And then it goes down 3, so negative 3. F is 2 across and then 0 up. Okay, so now let's have the coordinates of the x-intercept and the y-intercept. And this is the point where it cuts or crosses and the x-intercept is the x-axis and the y-intercept is the y-axis. So what point lies on the x-axis? Let's have a look where we can see that's point F at 2, 0. What point lies on the y-axis? It's E at 0, negative 3. Now, what's the center of the graph called? Well, let's add it here, put a dot. That's O, okay? Now the origin, or simply O, just means the center of a Cartesian plane. Okay, so the center of the graph is called the origin, denoted by the letter O, and it's 0, 0. So if in doubt, just put a 0. Okay, next we're going to look at some tables of values. Now, how does this work? Well, you've got some x value here, okay, and think of this as a machine. What you're going to do to that is you're going to times it by 2, then you're going to take 1 from that, and out pops your answer of y. So it's like a machine like that. Now, a way you could show that is you've got your x value, you put it in, and you times it by 2. Then what the answer is, you take 1 from it, and out pops your y value. Okay, so let's have a look. Now it's saying generate a table of values for the function that y is equal to 2x take 1 for the values negative 2 up to 2. So let's put that in. That's what it's saying by the x values. Now what we need to do is go, okay, 2 times by negative 2 take 1. That answer is going to go there. So that's going to be negative 4, negative 5. And then this one's going to be 2 times by negative 1 take 1, which is negative 3. And then you put in a 0, which makes negative 1, then 1, then 3. Now hopefully you've noticed this pattern. It's going up by 2 every time. And that reflects the gradient as well. So now they're asking you to sketch that function. So negative 2, negative 5, we don't quite have that value on there, but we can put this one there, 0, negative 1, 1, 1, and 2, 3. So there we go, we've got our function, and now we can draw a line between it. And we can even write this as y is equal to 2x take 1. Now, a bit more key theory. Later on we learn, and we can review it now, that this part's the y-intercept. Let's double check that. Yep, that's the y-intercept there. And the bit in front, this 2, is the gradient. Now 2 means 2 over 1, and we may remember rise over run. That means if I'm going across 1, as in it runs 1, it's rising up 2. So cross 1 up 2, cross 1 up 2, cross 1 up 2. Let's double check this works. Cross 1 up 2, cross 1 up 2. We can see it seems to be following that pattern too. So it's a bit of other theory that we learn a bit later, but we can review it now. Okay, let's have a look at the next one. These are called special lines, and they are just horizontal lines or vertical lines. Now the rule of thumb is if you've got a vertical line, the rule is x is equal to, and then you just put the x-intercept number there. And if it's a horizontal line, you go y is equal to, and then you put the y-intercept here. So let's have a look at this. Let's do A first. Now A, as we can see, is a horizontal line, so it's going to be y is equal to the y-intercept. Now the y-intercept in this case is 3. So this is the y-intercept. So therefore we just say y is equal to, and in this case, 3. That's our equation. Okay, let's have a go at B now. Now B is a vertical line, so we're going to be using the, vertical, and I'll draw a picture. That's vertical, that's horizontal. That may help you. So vertical line for B, x is equal to, and let's find out where it cuts, 1. So the x-intercept is equal to 1. So we go x is equal to 1. Let's have a go at C now. I'll choose green. C is a vertical line again, so it'll be x, and where does it cut the x-axis? -4. So if you want to remember this, it cuts the x-axis, so x is equal to -4. Last one is D, and let's go red for that one. It's a y, it's cutting the y-axis, therefore it's a y equals something, and it cuts at -2, so therefore y is equal to -2. Now these are called, these are special lines or flat lines, and we can see here that this is the strategy for tackling them. Okay. Now, what we're going to do is we're going to skip this for now. We'll come back to sketching graphs and intercepts. We're going to have a look at gradients, okay? Now, for gradients, the gradient is the slope of a line. So if the, you can talk about the slope of a line, it could be positive, it could be negative, it could be steep, it could be not so steep. So what letters used? M, and we can say for the gradient is equal to rise over run. Now don't ask me why these letter M, but that's our equation. Now rise is either up, and that's positive, or down, which is negative, and run is going across. Okay, so how far did you go across, and how much did you go up or down to get to the next point on the line? So let's draw some pictures. These are the types of gradients. You might have something like this. This is called a positive gradient, and we remember this like we've got a guy, he's moving up, and he's getting more money, or he's getting more friends, he's happy, he's going up the social ladder, so he's having positive life outcomes. Okay, the next one we may have is negative. Now negative is when you're going downhill, okay, and maybe you're losing a bit of money, not very happy, to going downhill in life. Okay, it's great if you're on a bike, but maybe not when you're losing money. 0, we can just do that. So if something has a 0 gradient, you're just on the flat. It's got no slope, if you want to think about it. So 0 slope. And I don't know, you just got the same money and a neutral expression on your face. The next one is undefined. Now undefined is a vertical line, and it's just you falling. You're just falling down. So it's not really possible to calculate a gradient. We just say the slope is undefined for this one. Okay, so now what we're going to do is find the gradients of the following segments. Okay, now what I'm going to do, I'm going to link them up. Like that. So what's the gradient of A to B? Well, it's going across 2 and then down 1. Now we know if it's going down, it's going to be negative. So what's our gradient? Well, we know it's going to be rise over run. Now the run is 2. That's the run there. And this is the rise, and it's negative. So it's going to be -1. So what's our answer? M is equal to -1 on 2. And you can write this as, if you want, -half. They're both the same thing. So we found the gradient there. There's another strategy of doing this. You can actually go down first and across second. That's okay. -1, 2. And the same answer will come out. So it's fine which way you go around on that one there. Let's have a look at BC now. The gradient we can see for BC is just flat. So that's easy, 0. Okay. And you can think of it as rise is going across 2 and then up or down 0. So you can say 0 on 2. That's rise over run, which is just 0. So we just say 0. CD, we can see now that it's positive. It's going uphill. So it's going cross 2, up 2. So here we go. M is equal to rises 2 on 2, and it's a positive. It's a positive gradient. And we can simplify that. M is equal to 1. Okay? Now, whenever we have a number floating there just by itself, like M is 1, M is 3, it's always 3 over 1 or 2 over 1. So this is equivalent of saying 1 over 1. For every 1 it goes across, it's going up 1. So it's a really handy strategy to think about. If a number's just floating there, put it over 1. Here we go, DE. Now DE, we are going across 1 and then down 1, 2, 3, 4. So we can say 1, 2, 3, 4. So it's going down 4. So we say that the gradient is 4 over 1, and we see it's a negative gradient, so we're going to make it -4 over 1. We can simplify this to M is equal to -4. But remember, as before, you can still say it's 4 over 1, which helps you think about how it moves. Cross 1, down 4, cross 1, down 4. Okay, now with this, we're going to look at some gradient intercept form. So, gradient intercept form, this is a linear equation. And remember, linear means line. Do we see that key word in there? So this equation will always make a linear function. Now, M is the gradient. And C is the y-intercept. Okay, and so let's picture you've got a y-axis here. It might pass through here. That's your y-intercept, and it might be like +1, or you may have another line. It might be going like this down here, and the y-intercept might be -2. So it's where it cuts the y-axis. Now x here is our x input, so you might plug in a 1, and what happens with the y? That's your output. So if I plug in 1 into my formula, I will pop an output y. Okay, so find the rule for a line of gradient 3 and a y-intercept 2. Now I like to do these like this. Y is equal to something x plus something. So we're thinking we need to replace the m with a value, and then we need to replace the c with a value. Now what's the m in this case? We can see that the gradient is -3, therefore m is -3, and a y-intercept of 2. Therefore, c is equal to 2. Let's plug those in. -3 plus 2. Rewrite. Y is equal to -3x plus 2. And this here will make an equation, or this equation will have a y-intercept of 2 and a gradient of -3. And that's how this equation works. We've got one more here, a gradient of 2/3. So therefore this is our m, which passes through the point 0, -2. Now this one may be a little bit tricky, but let's cast your mind back to this example over here. We know that a y-intercept is always, in this case, 0, 3. So x is 0. Let's look at another y-intercept. Down here, the -2. This is going to be the coordinate 0, -2. So if I ever want to find a y-intercept, x is always 0. Okay, so if x is 0, then we've found a y-intercept. Okay, so in this case, the y-intercept will be -2. And there's our answer there. Now, what I like to do, something x plus something, and substitute in what we do and what we know. Now, this, remember, was the m part, and this is the c part. So this is going to be 2 on 3 plus -2. Let's clean this answer up. Plus and negative just becomes negative. And there's our answer. Y is equal to 2 on 3, x take 2. Great, well hopefully you enjoyed this video and got a bit out of it. In the next video, we're going to be looking at sketching graphs of linear functions. Thank you.